Okay, we're alive here. So, adding and subtracting mixed numbers. Adding and subtracting mixed numbers. So when I write this stuff on the board, make sure in everybody's notes you're writing it too, okay? It's really important that you have, do you have your notebook? Do you have a notebook?
I don't have a notebook, I just have notes.
And oh, that's how you're taking your notes?
Yeah.
Okay, that's fine.
Can I get my notebook in my locker, please?
Yes, you may. Okay, adding and subtracting mixed numbers. Now mixed numbers, fractions scare people, but now you guys realize they're not that scary, right? They're actually pretty easy. All it is, it tells you how many pieces of a pie there are and how many you get to eat, right? Or how many pieces of pie are left. That's all fractions are, right? Adding and subtracting mixed numbers starts to kind of freak people out. Okay, what? You have to think a little more, right? So a mixed number would be like 2.5, and then say plus, well actually, let me do 2 1/4 plus 3 2/4. Okay. When you're adding, sometimes it's easy to just leave them in mixed number form, right? And just add, so this is, I have 2 plus a part of a pie, right? Plus 3. So in other words, I have 2 pies plus part of a pie, plus 3 pies plus part of a pie. So do you think it would be legal to say I have 5 pies plus the addition of those 2 other parts? Is that okay?
No.
It actually is okay. It's actually okay. Because that says I have 2 pies and 3 pies. So I have 5 pies plus 1/4 and 3/4. Really, I could even put a plus sign in between here. Watch this. I could do this. Just so you know, this is not how I'm going to tell you to solve it. But this is what that's really the same thing. That's what a lot of people don't realize. All that means is 2 pies plus 1/4 of a pie, plus 3 pies, plus 2/4 of a pie, right? So, and there's this amazing property. Does anybody know what the property is that says you can move things around when they're plus signs? Does anybody know?
The commutative.
Yes, the commutative property. When your dad or mom goes to work, they commute to work. Do you know that word? Yes. They commute. They get in their car and they commute. They drive, right? They commute. That means they move, right? So I wish they made it the moving property, right? It may be so much easier to remember. But commute. So it basically means as long as it doesn't matter where I put them. I could rearrange it. 2 plus 3 plus 1/4 plus 2/4. By rearranging it, suddenly this becomes a very easy problem. Look at that. What is 2 plus 3? 5. Plus, what is 1/4 plus 2/4?
3/4.
3/4. So 5 plus 3/4 is the same as 5 and 3/4. Does that make sense? Do you get that? All it is, you're just adding them, right? It's pretty easy. Sometimes though, there's an extra problem. And that extra problem is that when you add your fractions, you get something bigger than 1. You actually get an improper fraction. So let's try this one. So that was our first problem, number 1. Here's number 2. So let's say I had, let's say I had 4 and 2/3 plus 5 and 2/3. Okay? So if I use my same philosophy here, same theory, I could say, well, that's 4 plus 2/3 plus 5 plus 2/3. And that means, I can commute. I could put the 5 over by the 4. I could say 4 plus 5 plus 2/3 plus 2/3. And now I've got my whole numbers together and I have my fractions together, right? So what does that give me? What's 4 plus 5?
9.
9. Right. and then plus. Now what is 2/3 plus 2/3 as an improper fraction?
4/3.
4/3. 4 plus 4/3. Now, would it be okay to write this as 9 and 4/3?
Yes.
No. You just wouldn't see it. It's okay. I mean, nobody's going to arrest you. But, you know, it's not traditional. You won't see it written like that. Because 4/3 is, what would that be? So I'm going to erase that. Let's keep going. Let's say 9 plus, let's write this as a mixed number. So what would that be, Molly?
1 and 1/3.
So 1 and 1/3. But 1 and 1/3 is the same as 9 plus 1 plus 1/3, right? With me? You got that? So what's 9 plus 1? So 10. So my final answer is 10 and 1/3. Right? Does that make sense? Fist to 5. I just want to know if you're with me. Okay? Now, I've been nice to you so far. How have I been nice to you?
You've been explaining everything?
Say what?
You've been explaining everything?
Yeah, I've been explaining everything. And what do you notice about the denominators, Gabe, of the fractions?
Equivalent, and you're not giving a subtraction.
Yeah, both of those are problems, that I haven't given you yet, right? I haven't given you ones where they have different denominators, and I haven't given you subtraction problems. Subtraction problems are much easier to do using and converting to improper fractions most of the time. And in fact, you can always do these by converting to improper fractions as well. The trouble is, there's lots of ways to do these, right? There's lots of ways to solve problems in math. So I'm going to erase this. Let's do. I'm gonna show you now how to do it with improper fractions. Okay. So I'm gonna say using improper fractions. The beauty of this is it always works. It works for adding mixed numbers. It works for subtracting mixed numbers. There's no special clauses, special things you have to remember. It always works. So for all those problems I put up on the board before, it would work fine. And for all the harder stuff, it works fine. So let's say I gave you this. Let's say I gave you 3 and 2/5 plus 2 and 4/6. In this case, I could do that other method, but I don't want to. I'm going to try it in turning it into improper fractions. You guys remember how to do it? Okay, listen, how would you change this into an improper fraction?
Improper fraction, you would do 5 times 3, which is 15 plus 2, which is
Okay, so
17.
3 times 5 is 15,
Yeah.
plus these 2 more, that's 17. So I have 17 over 5. Plus, now, okay, another, Weston, help me with this one.
Okay, 2 times 6, and, sorry, I don't really know this
Which
number.
is 12, right?
Yeah, 12.
So 2 times 6 is 12, plus the numerator.
Okay, so 11, 16.
So 16 over that denominator.
Okay.
Okay.
16 over 6.
So suddenly you have a problem very similar to last night's homework, right? And so you ask yourself those questions. Do I have a common denominator? No, I don't. All right, the next question. Can I turn the smaller denominator into the bigger denominator by multiplying them something? Not really, right? So that means I got to multiply both fractions, right? So if I can't think of anything smaller than 5 times 6, I can always use 5 times 6. Actually, I think that is my lowest common denominator in this case. So what would I put here? 6, and up here I put 6. Here I put 5, and here I put 5, right? So now I just have to multiply this out. Wouldn't you know I do one that I don't know. Whoops. Let me know what that is. All right, 42 for 104, am I right? Did I do that right? 104 over 30 plus, and then 5 times 16, 5 times 6 is 30, 5, 80. So 80 over 30, did I do that right, Evan?
1 second. We're going 5 times 16.
Yeah, 5 times 16, did I get 80? Did I get the 6 times 17 right?
6 times 17.
Did you get 104?
So
42, 4, 6, 79, yes. Oh, 102, sorry. 102, I apologize, 102. Yes, 102. All right, so then my final answer is what? 182 over 30. 182 over 30. And then I have to just divide if I want to simplify. Well, I know, let's just, instead of using, let's just use some practical things. What do we notice about both these numbers? What were you going to say, Graham?
I was just going to give you the answer.
Oh, you're going to give me the answer. Before you give me the answer, what's your answer? Tell it to me.
6 and 2 thirds.
6 over
6 and 115.
6 and 115. Okay, so they're both even, right? So they're divisible by 2, right? Anytime you have an even number, it's divisible by 2. So we'll try that. Divide by 2. Maybe that'll get us into easier formats. 15. Half of 18 is 9. Half of 2 is 1. 91 fifteenths. Oh, I think 15 goes into 90. 15 times 2 is 30. 15 times 4 is 60. 15 times 6 is 90. So it's going to be 6, and then there's 1 left over. Well done, Graham. Good job. Right? So that's all you have to do. You make them improper fractions, and then do your method that I taught yesterday. You get your final, you get this big answer with big numbers, and then, if they're both, see if you can simplify it. The trouble is, that's the hard part, is trying to simplify these big numbers, right? If you used a calculator, you'd get a decimal. You get 6 point something, right? As a decimal. Okay, so that always works. What time is it? Okay. It works for adding or subtracting. So on the homework tonight, for adding, you can use this method, or you can use the first method I showed you. For subtracting, I would suggest you use this method. Okay, does that make sense? Use the improper fraction method for subtracting. It's going to be easier overall. Okay, now we are moving to a new topic. I mean, it's fractions again, but we're going to be multiplying fractions. And multiplying fractions, many of you are doing it wrong. Actually, that's not true. You're doing it the long way. You're making it really, really hard. Right? So, let's say I have 2/5 times 6/10. Okay? This is my first problem. This is now, by the way, a new section, right? A new heading for your notebook, right? And so a lot of people have been taught, and they're right, that when you're multiplying fractions, you multiply the numerator times the numerator, and then you multiply the denominator times the denominator, right? So that's fine with small numbers. So 2 times 6 is 12 over 50. Now, my brain, I see that and I think, I don't know what 12/50ths is. I have to reduce it. I know that, right? And I know they're both even, so I could divide by 2. You know, I could try those kind of things. It just would take me some time. I don't know exactly what to do. So 12 divided by 2 is 6. 50 divided by 2 is 25. That might be my answer. But let me show you an easier method. The easier way is to do this. It is to reduce. I don't know how to say this. Reduce upstairs, downstairs. All right, I know you're not going to see this in a textbook, right? You see numerators and denominators. I say upstairs and downstairs, okay, when I'm doing this. Because I'm going to do this all over again. 2, I'm going to use a different color. 2/5 times 6/10. All right, 2 is upstairs, 6 is upstairs, okay? 5 is downstairs, 10 is downstairs. You got it? So, is there something upstairs, some number that goes into a number upstairs, either of the 2 numbers upstairs, that also goes into either of the 2 numbers downstairs? 80. 2 goes into 10. 2 does not go into 5, but it goes into 10. So, and I know 2 goes into 2. So I'm going to say 2 goes into 2 once. So I cross that 2 out because I'm technically dividing. So 2 divided by 2 is 1. And I'm going to do the same thing here. I have to, if I do it upstairs, I have to do it somewhere downstairs. So 2 goes into 10 5 times. Now I'm going to ask myself, is there anything else upstairs that goes into something downstairs? Or something that goes into both upstairs and downstairs? I have a 1. 1, you're never going to get lower. 6, 5, 5. Nope. So my final answer is 6. 1 times 6 is 6. Over 5 times 5 is 25. The beauty of this method is I'm dealing with tiny numbers here that are really easy. I know my 2 times 5 is 10, right? I don't know that, you know, well, I know. When they get harder, when they get bigger, the numbers get bigger, I don't always know my times tables up to 257, right? I don't know that. But I know I'm up to 10. I know I'm up to 100. Easy, easy, easy. So suddenly, when I do this, my answer is already in simplest form. I don't have to simplify. When I do this, bummer, I get this doggone sort of nightmare kind of a fraction that I have to simplify. Ram.
Isn't it usually called cross-reducing?
Yeah, it's called cross-reducing. The reason I don't say that is because it's not just cross-reducing. It's not just these 2. It's also these 2 and these 2. You know what I'm saying? It is called cross-reducing, but that's why I don't use it, because it people think they've got to be this way. They don't. So let's try another problem, and I'll show you what I mean. So 2. Let's say I had 3 6 times 12 fifteenths. So I'm looking for a number upstairs that goes into a number downstairs, or a number that goes into something upstairs and something downstairs. 8.
6 goes into 12.
All right, so 6 goes into 12. So he's now doing cross-reducing, right? Right? But some people might have said, oh, well, 3 goes into 6. So then it's not cross-reducing, it's upstairs, downstairs. You know what I'm saying?
Yeah.
And I didn't know what else to call it. So that's why I'm calling it that. You know what I mean? That's why I say upstairs and downstairs. But, so you could have done it either way. You'll get the same answer. So 6 goes into 6 once. 6 goes into 12 how many times?
Twice.
Twice. All right. Is there anything else I can do? Yes, listen.
3
3
and 15.
and 15. 3 goes into 3
1.
once. 3 goes into 15
5.
5 times. Is there anything else I can do?
No.
The ones, once they're down to ones, you can't do it. You can't go any further. 2 and 5, those are my only two other options. They don't go into anything. So my answer is 2/5. Now, had I not done this method, had I used this method, I would have gotten 36 over 90. 36 over 90. In my brain, I don't know what that is. I don't know what that is. I don't know how to simplify that quickly, right? I don't know. Immediately, 36 over 90 is 2/5. Yes, everybody knows that. No, I don't know that. I'd have to figure it out. Did you see how easy this is? You guys, 5ths to 5. Do you understand? Is it making sense? Right? Is it? Yes! Yes! You guys rock. Okay, one last one. And then we're done. What if I gave you something like this? 4 ninths times 2 twelfths times 18 24ths. Now, I would not want to multiply that all out and then have to reduce that fraction, personally. That would be a bummer. And from a math teacher, that's saying a lot, right? That's a bummer. It would be a bummer. But I can cross-reduce. Excuse me, not, I can do upstairs, downstairs reducing, right? Okay? And it doesn't matter. Let's say I see, the 4 and the 24. I'm skipping this one completely. That's fine. I can do that. 4 goes into 4 once. 4 goes into 24 6 times. Beautiful. Now I don't have that doggone big 24 over scaring me. Right? Now let's see. 2. Look at this. That's now a 6, but 2 goes into 6. Right? So 2 goes into 2 once. 2 goes into 6 3 times, right?
Yeah.
All right. And then, is there anything else I can do? Mara.
9 and 18.
9 and 18. Is that what you're going to say, Kima?
Yeah.
All right, 9, 18. So 9 goes into 9 once. 9 goes into 18 twice. Is there anything else I can do?
3 goes into 12.
Okay, but 3 is on the downstairs and the 12 is downstairs. So they got to be, one has got to be downstairs, one's got to be upstairs. Anything else? So, Emily.
2 and 12.
The 2 and the 12. Okay, so 2 goes into 2 once, right? 2 goes into 12 6 times. So what is my final answer? 1 times 1 times 1 is 1. Over 1 times 6 times 3, 18. Now that is easy. That is easy, right? The reason this is important is math in algebra will get quite complicated sometimes. And you will have to know how to do this kind of reducing upstairs and downstairs, because it's not going to be just numbers. There's also going to be x squareds, y cubes, z to the 13th, right? And so we're going to have to know how to reduce not only the numbers, but the variables, both upstairs and downstairs. And so that's the lecture for today. And I'm going to stop there.